everyone, and welcome to our Engineering Ambassadors Tour video.
So right now, we're standing outside of the Herbert Wertheim Laboratory for Engineering Excellence building. For those of you who do not know, Dr. Herbert Wertheim is an optometrist and inventor. He graduated with his electrical engineering degree from the University of Florida. He went on to found Brainpower Incorporated, which is an optical manufacturer for tints and eyeglasses. He was kind enough to donate $50 million to aid in the construction of this building.
This was the catalyst for a $300 million public and private partnership that was meant to support our dean's goal of powering the new engineer. So a lot of the time people say they don't actually know what engineering is. So this building was built entirely of glass in order to highlight spaces in which engineers are working together, collaborating. We also have slanted windows on the side of this building that highlight collaboration spaces. And one of those windows is Herbert Wertheim's office. Inside the Herbert Wertheim Laboratory for Engineering Excellence, we have a lot of unique features. If you look to my right, one of those is our freshman design lab. This class hosts Design and Society. This is a class where students can focus on human-centered design and working on a prototype from start to finish. It provides the opportunity for engineering majors to work interdisciplinarily between different majors. This class also teaches a lot of foundational engineering skills such as 3D printing, working with Arduino and circuits, as well as coding.
So behind me, we actually have a prototyping lab, which is home to $5 million worth of equipment that students can get access to either by taking a one-credit class or talking directly to the lab manager. So within that $5 million, we have a ton of really cool equipment that is accessible to students whenever they need to use it, such as our fused model deposition lab, which includes a bunch of 3D printers and 3D scanners, and our only 3D printer of metal on campus, and a 5-axis water jet, mills, lathes, you name it, it's probably in there. So students who are on different design teams can access this, and one aspect of that design team is our IPBD program. Integrated Product and Process Design is a program in which you can replace your senior design project with a project that you're solving for a company. So UF works with a lot of notable companies to facilitate this process, such as Boeing, Siemens, Dell, Motorola, and Disney, just to name a few of them. And all of these projects are something that students own from start to finish, in which they're working with a team to solve a problem, very similar to the freshman design lab, except now it's something that gets them real exposure to the industry before they have to actually start.
In this building, we also have our first year advising office. Our college is the only college on campus to have a first year advising office just for freshmen. So that helps freshmen who come into the college knowing that they want to do engineering, but not knowing which type of engineering they want to do. When freshmen switch their majors, they get to have one engineering advisor that stays with them the whole time, instead of having to switch advisors while they're switching their majors. In that office, we also have our engineering peer advisors. They're there to give you advice and experience from their freshman years of college to help you decide what engineering major might be right for you or what classes you want to take. If you are a student that's struggling with choosing your major, we also have several other resources for you. For example, we have a one-credit class called Intro to Engineering, in which you could go to different lab spaces for all the different types of engineering majors and talk to key faculty from each major to help learn more about it and help you decide what engineering major you want to take. We also have the Exploratory Engineering major. This is a major you could be in for up to 3 credits or for up to 3 semesters that will help you where you take just general engineering classes while you're figuring out what engineering major you want to choose after those 3 semesters.
Yeah, so on the note of majors, we also offer a plethora of minors and certificates. So on the 3rd floor of this building is home to our Engineering Leadership Institute and Engineering Innovation Institute, which both offer their respective leadership minors and certificates and innovation minors and certificates, where students can join and take classes that expose them to what engineering looks like beyond just the technical skills, where they can go towards either the leadership path or the innovation path. So one note is that students cannot pursue both at the same time, but they can find individual minors and certificates that they can take. And students have a great experience because they're learning things that they learn outside of the classroom while still being within the classroom and getting industry exposure.
On our 4th and 5th floors, we have our Global Teleconferencing Lab and our Biotechnology Lab. Fun fact, this building was built with 3 times the amount of concrete needed to provide a stable base for the equipment in the Biotechnology Lab.
And for our next stop, we're at the Nuclear Sciences Building, and you're never gonna guess what we're standing on right now.
We're actually standing on UF's training reactor. This training reactor was built in 1959 and the building was finished in 1964. This training reactor is one of less than 30 training reactors on college campuses in the United States. And this training reactor is currently being updated from being in analog to being in digital, and new HVAC system is being integrated into it. It can power 100 kilowatts, which is roughly 10 to 20 houses.
The UF training reactor serves two different purposes. The first one is training. Companies from around the Southeast will send their nuclear engineers to this reactor to train on a nuclear reactor in a smaller setting before working on an active nuclear reactor. Additionally, research is done on the training reactor. The training reactor will have different elements sent into its core via tubes that kind of look like bank tubes, and we can see how different elements react to radiation exposure. Nuclear engineering is the study of how we can harness atomic energy for a good purpose. Now, many people think that nuclear engineering is just defense and power, but it's used for many other applications as well, including radiological medicine to cure cancer, as well as in soil sciences to identify trace elements in different soils.
Right now, we are right outside the pit in Weil Hall. Weil Hall houses civil, environmental, and ag and bioengineering. Civil engineering has everything to do with adapting the features of the earth to our society. It's all about infrastructure and how things are built. The road you drove on to get here, the building we're standing in right now, was most likely designed and built by civil engineers. But 1 in every 4 engineers does work with civil engineering.
So spinning off that, environmental engineering is a specialization of civil engineering. Environmental engineers specialize a lot in trying to understand different ways that we can mitigate some of the human health consequences that we derive from things like air pollution, water pollution, and other things we might be emitting into the environment, and how we can revert that back into natural processes that the earth used to have. We also have our home to our agricultural and biological engineering stops here in the civil pit. Agricultural and biological engineering works to try and understand how we can develop different types of fuel processes from naturally occurring biological systems, and how we can mass produce different types of foods so we can further feed different societies. Now we also have our stop for our study abroad offices. For engineering, a lot of people often think that there's not really opportunities to study abroad due to our demanding curriculum. However, the University of Florida makes it really easy to study abroad with an engineering study abroad office located here in the civil pit as well. We have a lot of opportunities for internships abroad and studying abroad, which make it really easy, and you get to study abroad in different locations found all throughout the world.
In the pit here in Weil Hall, we house 2 highly competitive design teams, Concrete Canoe and Steel Bridge. Both teams regularly compete for national championships. In fact, they both just won the title in 2025. The University of Florida is the only school to have both design teams win the national title in the same year. We have done it 4 times. And currently, Steel Bridge is on a 5 consecutive year winning streak. The Steel Bridge team, when they designed their bridge, they used AI algorithms to find the perfect ratio of strength to weight within the bridge to optimize the design for a winning bridge. Additionally, many other schools will have other companies prefabricate their bridge, and the students just work on the design and optimization. At UF, we do all the welding and the entire fabrication of the bridge here in the pit. We do the design, the fabrication, and the optimization. In addition to those 2 design teams, the pit also houses the strong wall. Here, it's a hurricane testing wall, so we can actually launch different objects at hurricane winds to show how concrete will react and how different structures will be able to react during a hurricane, since we have so many in Florida.
So right now we're behind one of the UF 3D concrete printers that was hand-delivered last year from Denmark. The University of Florida is currently one of the only universities in the United States to have access to a 3D concrete printer, and we intend to use this 3D concrete printer to conduct different research to investigate how different materials in the state of Florida will react to weather conditions, humidity, and other factors that might impact it. The University of Florida has 5 of these modules that are going to be used to print their own engineering facility on East Campus of the university, and we're also planning on making other investments.
Here we are in Weil Hall, home to our donor wall, which is just behind me. The donor wall recognizes the individuals and companies that invest in our Gator engineers. The University of Florida is home to the largest career showcase in the Southeast, with hundreds of companies coming to just talk to Gator engineers. We recommend that students of all grades get involved and go talk to recruiters at Career Showcase to get practice with networking. We also have the Career Connection Center at the University of Florida, which is a great resource for students to do resume reviews, mock interviews, and we even have our Career Connections Closet where students can borrow professional attire. Weill Hall is also home to our Dean's Office. Our Dean's Office has an open door policy, so if at any point students want to go have a conversation with the Dean, they're welcome to walk in, and they can also make an appointment.
And finally, here in Weill Hall is home to the Industrial and Systems Engineering degree, also known as ISE. ISE is a combination of business, statistics, and engineering to solve complex problems and optimize them. Some common roles that people go into that are ISEs are manufacturing roles, supply chain, consulting, and even healthcare systems. And finally, some notable former Gator ISEs. Somebody went to Disney and saw that there were super long lines and thought, how could Disney make more money in the shops and dining halls? And they actually invented the Disney Fast Pass, which is really cool. And finally, the former CEO of Progressive was a Gator ISE, and a fun fact is that FLO is actually short for Florida.
Gator spirit is alive and well here at the University of Florida. One way that we like to show our school spirit here is through going to sports games. In fact, all of our sports games are free to attend, except for football, and basketball will be free, except for some restrictions based on some of the bigger games.
Yeah, so right here is our Ben Hill Griffin Stadium, where some of you may know it as the Swamp. It is actually the largest college football stadium in all of Florida, the 12th largest in the United States, and the 18th largest in the world. It was originally built on a massive sinkhole, so the playing area is encapsulated by the stands. And so that makes the sound reach up to 123 decibels. And just for reference, a jet engine is around 130 decibels.
And across the street from Ben Hill Griffin Stadium is the O'Connell Center. The O'Connell Center is where men's basketball, women's basketball, men and women's volleyball, and gymnastics are played. It's a great place to watch a game.
Right here also on this corner has Gator Corner Dining Center. So this is one of the primary dining halls on campus. Conveniently close to a lot of things like the stadiums, like Weill Hall and other buildings, and also some of the dorms.
Speaking of dorms, next to Gator Corner Dining Center is East Hall. This is where our engineering living learning community is. This is a great place to live if you want to meet other engineers in your first year and meet like-minded individuals. Living on campus is a great way to stay connected to the campus community at the University of Florida.
So currently we are inside one of the laboratories in Rhines Hall, which is the home of the Department of Material Science and Engineering. So this is an undergraduate lab where students get hands-on learning experience on the topics that they've been being taught throughout their undergraduate careers. Behind us are a bunch of the 3D printers inside of this lab. So there's some plastic printers, some of which have millimeter precision and some which micrometer precision, which is 1/1,000,000th of a meter, which is pretty cool. There's ceramic printers that use laser printing to etch out solid objects.
Yeah.
There are bioprinters, which are able to create tissue for cell growth. And there's actually a moon dust printer in here that is used for research. So in the event that we one day go back to the moon, we want to be able to create tools and equipment out of moon dust so that we don't have to bring all of these heavy equipment with us. So it's a bunch of cool printers in here, and one of the other pieces of equipment is down on the other side of the lab, and it's called an SEM, or a scanning electron microscope. So like any microscope, it has the ability to zoom in really close onto something. So when you're in elementary school or middle school, maybe you worked with an optical microscope that uses light waves to see something really close up, and that maybe had 100 or 500 times magnification. But a scanning electron microscope uses a focused beam of electrons. So electrons are a lot smaller than light waves, and thus it can see much closer, and it has hundreds of thousands of time magnification. Another really cool part about a scanning electron microscope is that first term, scanning. So you can take some kind of material, and it can take a scan of it and determine the composition of that material. So it can look at something really closely, it can identify the composition, it has a lot of great resources, and it's a great opportunity for material science students to get that hands-on learning.
So speaking of material science engineering, it is an engineering major that is highly focused on chemistry. So if you find yourself very interested in chemistry and the applications of it in engineering, then material science engineering might be the major for you. It is what we like to call a found major, meaning that students don't usually come into UF deciding to be a material science engineer. They usually find it during their first or second year here as an engineering student and decide that that is the major for them. Material science engineering is also the most funded major in the college for research, with approximately $10 million annually dedicated specifically towards research in the department. Another related major to materials engineering is chemical engineering. So while this may sound like it is very chemistry heavy, it is a lot more based in physics. The way that we kind of like to compare the two majors is by using an analogy of cooking. So if you think about a baker who develops a recipe, the material science engineer would focus on developing the perfect cookie recipe with the right ratio of ingredients and trying to optimize the specific recipe. The chemical engineer would focus on taking that specific cookie recipe and scaling it up in a process to produce tens of thousands of cookies that are all exactly the same and follow that specific recipe.
Welcome to Malachowski Hall. This is the newest academic building on campus, where construction started in 2020 and its first active semester was spring 2024. It is also the largest academic building on campus, spanning 7 stories and having over 263,000 square feet.
So with this building taking up so much space on campus, the architects who designed this building made sure to make a lot of environmental considerations in the design before actually coming into fruition. Some of the neat design features behind this building include some dots printed throughout every single window on this building. Since this story spans all the way up to the 7th story, the dots are helpful to help prevent any birds flying at higher elevations to crash into the building and having unintended consequences. There's also electrochronically plated glasses throughout the entire building. Since we live in the Sunshine State, this was a neat design feature that was incorporated to help control the amount of sunlight that gets in and outside the building. By doing this, we were able to offset a lot of the amount of energy and electricity costs that come associated with running the AC and ventilation systems within this building. In addition to that, the top roof of this building is also layered with a solar array that offsets about 10% of the energy costs within this building. This building also uses about 60% less water than a building of this size would typically use, which were all design features that helped lead to the Platinum LEED certification that this building currently holds.
Yeah, and speaking of costs, this building cost approximately $150 million to make. This was catalyzed by a combined donation of $50 million from Chris Malachowski, the namesake of the building, and his company NVIDIA. NVIDIA is a company that makes graphical processing units for GPUs, commonly used in gaming, but also now being used in a lot of AI applications.
Speaking of AI, the University of Florida has a great partnership with NVIDIA, which has provided us with many resources here on campus to be able to continue our research. The University of Florida currently has access to one of the world's largest and fastest academic supercomputers here on campus. This is poised to help researchers, faculty, and other students here on campus continue to develop and understand ways that this technology can further benefit their research labs. In addition to that, the University of Florida offers an AI undergraduate certificate program, which is only a 9-credit program to students all across campus. This certificate program is poised to help all students here on campus, regardless of their major, learn and understand the basics of AI.
Here we are in Malachowski Hall. Malachowski Hall is home to the Electrical Computer Engineering Department, along with data center operations for College of Pharmacy and College of Medicine. It's also home to a lot of student spaces and collaboration spaces, like the one in front of me, which is called the Collaboration Spine, where students can hang out and do homework and meet up with their friends.
And then going off of this collaboration, we also have many student orgs that have their offices here. They're right here to my right. And there's over 1,000 plus student orgs on campus that are student run. And here at Engineering Ambassadors, we like to have the rule of 3, which means getting involved in a technical org, a social org, and a professional org. A technical org will be your design teams. This is getting that hands-on experience in the engineering field of your choice. A social org is going to be something that you're interested in. This is a hobby. It could be intramural sports, it could be a baking club, anything that makes you happy outside of school. And then a professional org is helping those leadership skills and growing you for industry after college.
Yeah, so like I said before, Malachowski Hall is home to the electrical computer engineering department, along with computer science. So the best way to think of these majors is kind of on a spectrum. Over here you have electrical engineering, which is primarily your hardware focus. You'll be working on things like electronics, some digital hardware, but mostly you're dealing with the hardware level of stuff. Then on the other end you have computer science. Computer science is dealing mostly with the software side of stuff. So you might be writing programs that could eventually utilize the hardware that the electrical engineers use. Then in the middle, you have computer engineering. That's kind of the merger between the two worlds where you're working on hardware and software. Usually you're doing something like firmware engineering where you're writing software for hardware. And then along with that, we have digital arts and sciences, which is a major that kind of combines your artistic side and creativity along with computer science. So you take a lot of those core computer science classes along with arts, so you can work on things like visual effects or animation and the tools that go behind that.
Welcome to the new engineering building, also known as NEB. This building was opened in 1997 and sponsored by a $1 million donation from the Harris Corporation. It is 6 floors tall and has 144,000 square feet of space. So it's also home to numerous labs and classrooms. Speaking of classrooms, UF offers 3 different types of classroom options. We offer a flipped classroom, a traditional classroom, and an online classroom. Online classrooms are when you take your class online. Traditional classrooms are when you go to class, you're lectured, the professor lectures, and you take notes and do the homework at home. But a flipped classroom is when you learn the material outside of class and come to class to ask questions of the professor and do example problems, which is a more enriching way to learn. Also in close proximity, we have the biomedical laboratory, which is down the hill closer to Shands. Biomedical engineering uses engineering principles to solve problems in medicine and biology to enhance overall healthcare. There are tons of different applications of biomedical engineering, some of which include COVID tests, prosthetics, and artificial organs. Biomedical engineering at UF is a little bit different because it's a limited enrollment program, which means that when you apply, you are accepted as a pre-BME, and then in the fall of your sophomore year, you have to reapply to get into the upper division. We recently just received a $100 million donation from the Dr. Nicole and Herbert Wertheim Foundation, which is the largest gift from an individual donor in university history. Now let's head inside NEB.
So now we're inside the new engineering building and we're going to talk about mechanical and aerospace engineering. Mechanical engineering is the study and manipulation of inputs to achieve desired outputs. Basically anything that moves. Anytime something moves, anywhere, any place, the mechanical engineer is involved.
And aerospace engineering is, like Zach said, anything that moves, but specifically in air and space. So we're concerned with aircraft and space. At the University of Florida, we also have a dual degree program. So you can get both a bachelor's degree in aerospace engineering and mechanical engineering. And it's only 9 extra credits, which is 3 classes. Here at UF, we also have a 4+1 degree program. What that means is that you can take graduate classes during your undergraduate degree, so that you can graduate with your graduate degree 1 year after you end your undergraduate degree.
Our wind tunnel lab allows for students to get hands-on experience in their coursework. This allows for them to get experience using the equipment and gather experimental results, which they can compare to real-world data. This wind tunnel is available for undergraduate use, and UF is one of the few universities across the country where undergraduates can use this equipment. This wind tunnel operates similarly to blowing air through a straw, where it takes a large quantity of air and compresses it, where it can reach high speeds in the chamber of up to 110 miles per hour. This wind tunnel can be used for both academic and design teams, for example, senior design or our automotive or rocket teams. One neat feature about these wind tunnels is that they're anechoic, so as not to disturb all the offices and classrooms around this, the sound collapses at itself on the end, so it does not create too much disruption.
We're currently outside the diesel engines lab. So in this lab, students can take apart and put back together a diesel engine. This is one of the upper level mechanical engineering labs. And in this lab, you apply techniques and skills that you've learned in your earlier classes in a hands-on environment.
Thank you everyone for joining us on our Engineering Ambassadors Tour. We hope you learned a little bit more about what makes Gator Engineering so special. Go Gators!